This is a simple and cheap solar water heater that will probably be described in one of my future videos. But now I will compare its heat production with this case when I added mirrors, and you will see that the mirrors have noticeably increased its capacity and heating temperature. Let's memorize this temperature of the water, which goes into the solar heater, goes through it, and exits here, where the water has this temperature, which is 11 degrees Celsius more than the inlet water temperature. Unfortunately, this measurement method is not accurate, and now we see that both sensors show slightly different temperatures. But their data must be the same, because these wires tell us that now both sensors measure the water temperature in the same place. That is why I will only use one sensor, and let's memorize this temperature, 25 degrees Celsius. Now we see that it was the temperature of the water at the inlet of my solar heater, and then the same sensor will measure the temperature of the water at the outlet of the heater. In addition, we must memorize this time when the water began to fill this mug with a volume of 1 liter. So, the mug is already finishing filling, and this is the temperature of the water that went through my solar heater where it was heated by solar energy. All this information allows us to calculate the thermal capacity of the solar heater, and this is my calculation. We must memorize this number, which is the capacity of the water heating by my solar heater without any mirrors, and we will compare it with this case of the same heater but with 2 mirrors. Here we can see a barely visible spot of solar radiation from the mirrors, and we understand that this additional solar radiation will increase the thermal capacity of my solar heater. Therefore now the same heater but with mirrors will go through the same experiment. So, we must memorize this temperature, 24 degrees Celsius, and it is the temperature of the water that comes into my solar heater. In addition, we must memorize this time when the water began to fill the mug. We also memorize this water temperature at the outlet of the solar heater, which is almost 36 degrees Celsius, and this clock tells us that 1 liter of the water filled the mug in 1 minute and 35 seconds. So, all this data gives us this calculation of the capacity of the solar heater with mirrors. The thermal capacity of my heater with the mirrors is here, and we can compare it with this capacity of that case of my solar heater without any mirrors. So, we see that the addition of the mirrors increased the thermal capacity by more than 2 times. Now I will show another experiment when I measured the maximum heating temperature of my solar heater with the mirrors. We see that the maximum water temperature was 74 degrees Celsius, and it is 48 degrees above the ambient temperature. This is a similar experiment, but now my heater does not have any mirrors. That is why the maximum temperature has decreased to a level of 50 degrees Celsius, and it is 26 degrees higher than the ambient temperature. So, we have seen that the addition of those mirrors increased the difference between the maximum heating temperature and the ambient air by almost 2 times. Of course, those effects of increasing the thermal capacity and maximum heating temperature depend on the size of the mirrors, their tilt angles, and other causes. For example, I can add similar mirrors also here, above the solar heater, and they will increase the capacity and maximum temperature additionally. I must warn you that solar radiation from mirrors can damage or destroy many types of solar heaters. But this homemade heater is not afraid of any additional solar radiation, and therefore I can use it with various types of mirrors.